Imagine a cosmic enigma so powerful it bends the very fabric of space and time. A celestial phenomenon that defies our understanding of physics and challenges our perception of reality. Welcome to the mind-bending world of black holes. But what exactly is a black hole? Contrary to popular belief, it's not actually a hole in space. Instead, picture an incredibly dense mass of matter, compressed into an unimaginably small volume. This concentration of mass is so extreme that it creates a gravitational pull so strong, not even light can escape its grasp. How do these cosmic titans come into existence? The birth of a black hole is a spectacular cosmic event. When a massive star, many times larger than our sun, exhausts its nuclear fuel, it undergoes a cataclysmic collapse. The star's own gravity overwhelms it, causing it to implode with such force that it creates a singularity, a point where the laws of physics, as we know them, break down. As the star collapses, it leaves behind a region of space where gravity reigns supreme. This boundary, known as the event horizon, marks the point of no return. Once anything crosses this threshold, be it light, matter, or information, it can never escape the black hole's clutches. It's as if the universe has drawn a cosmic curtain, hiding the secrets within from prying eyes. But the influence of a black hole extends far beyond its event horizon. These cosmic behemoths warp the very fabric of space-time, creating mind-bending effects that seem straight out of science fiction. Time itself slows down near a black hole, a phenomenon known as time dilation. Imagine two twins. One remains on Earth while the other ventures near a black hole. When they reunite, the spacefaring twin would have aged less than their earthbound sibling. And if you were to fall into a black hole, well, you'd experience a process colorfully termed spaghettification. The intense gravitational forces would stretch you vertically while compressing you horizontally. Quite literally, turning you into cosmic spaghetti. It's a fate that even the hardiest of pasta lovers might find unappealing. While stellar black holes formed from collapsed stars are impressive, they're dwarfed by their colossal cousins, supermassive black holes. These cosmic giants, millions or even billions of times more massive than our sun, lurk at the hearts of most galaxies, including our own Milky Way. They act as cosmic anchors, their immense gravity influencing the motion of stars and shaping the very structure of their host galaxies. The existence of these supermassive black holes raises intriguing questions. How did they grow so large? Did they form from the mergers of smaller black holes, or did they arise through some other unknown process? The answers to these questions could revolutionize our understanding of galactic evolution in the early universe. But the mysteries of black holes don't end there. Some scientists speculate that these cosmic enigmas might be more than just dead ends in space. Could they be gateways to other universes or different regions of our own cosmos? The idea of black holes as cosmic portals has captured the imagination of both scientists and science fiction writers alike. Another perplexing puzzle is the information paradox. According to quantum mechanics, information cannot be destroyed. Yet anything that falls into a black hole seems to vanish forever. How can we reconcile these seemingly contradictory ideas? The solution to this paradox could lead to a unified theory of quantum gravity, bridging the gap between the physics of the very small and the very large. Recent breakthroughs have brought us closer to unraveling these cosmic mysteries. In 2019, the Event Horizon Telescope collaboration captured the first ever image of a black hole's shadow, providing visual confirmation of these elusive objects. This groundbreaking achievement opened up new avenues for studying these cosmic enigmas and testing the limits of Einstein's theory of general relativity. As our understanding of black holes grows, so too does their potential to revolutionize technology. Some scientists speculate that the immense energy generated by rotating black holes could be harnessed as a power source for advanced civilizations. While this remains in the realm of speculation, it highlights the profound impact these cosmic objects could have on our future. Black holes also serve as nature's ultimate laboratories, allowing us to test the most extreme predictions of our physical theories. By studying the behavior of matter and energy in the vicinity of black holes, we can probe the fundamental nature of space, time, and gravity in ways impossible to replicate on Earth. The study of black holes has already yielded surprising connections to other areas of physics. For example, research into the quantum properties of black holes has led to insights in the field of condensed matter physics, demonstrating how these cosmic objects can inform our understanding of phenomena on the smallest scales. As we continue to explore the universe, black holes remain at the forefront of scientific inquiry. They challenge our understanding of the cosmos, push the boundaries of our theories, and inspire us to ask profound questions about the nature of reality itself. From the collapse of massive stars to the hearts of galaxies, black holes are key players in the cosmic drama. They bend light, warp time, and may even hold the key to unlocking the deepest secrets of the universe. As we peer into the darkness of these cosmic titans, we find not just emptiness, but a window into the fundamental nature of existence itself. The next time you gaze up at the night sky, remember that among the twinkling stars and swirling galaxies lurk these invisible cosmic giants. Black holes may be dark, but they shine a light on the mysteries of our universe, inviting us to explore, question, and wonder at the incredible cosmos we call home.
Stay curious.